Hello everyone, I am Suchitra, student of Biochemistry in JSS Academy of Higher Education and Research, Mysore. With this video, I am going to start a video lecture series of monosaccharides, their definition, classification, examples, properties, and function. Before we knowing monosaccharide, we want to know about carbohydrate because monosaccharide is one of the type in carbohydrate. Now I am talking about carbohydrate. So, what do we mean by carbohydrate? If I break the word carbo means carbon, hydrate means water or H2O molecule. So, carbohydrate means which is have a carbon, hydrogen and oxygen. So, molecular formula for carbohydrate is CnH2nOn, which can also be said as n number of carbon and n number of water or H2O molecules. Carbohydrates are the polyhydroxy, aldehyde or ketones. Polyhydroxy means it has many hydroxyl group, which is OH group. And it will have either one ketone group or one aldehyde group. If the sugar molecule having ketone group is called ketosis, and if the sugar molecule having an aldehyde group is called aldosis. In this slide, we can see the classification of carbohydrates. Carbohydrates are classified into three groups based on the number of sugar units. First one, monosaccharides. Second one, oligosaccharides. Third one, polysaccharides. Now I am talking about monosaccharides. Before we start, let's get small introduction about monosaccharide. Mono means single, saccharide means sugar. The proper definition for monosaccharide is monosaccharides are simpler sugars which cannot be further hydrolyzed. They are represented by the general formula CH2ON or CnH2nOn. The important property of monosaccharide is that they are readily reduced by oxidizing agents. For this reason, they were called as reducing sugars. Monosaccharides are colorless, crystalline substances, sweet in taste. They are also soluble in water. Now we come to the classification of monosaccharides. Here we can see monosaccharides classified on the basis of carbon number and functional groups. In this table, we can see the classification of monosaccharide. First one, triosis. C3H6O3 is the molecular formula for triosis. Glyceraldehyde or glycerose are the example for aldose sugars. Dihydroxyacetone is the example for keto sugars in triosis. Second one, tetrosis. C4H8O4 is the molecular formula for tetrosis. Erythrose and threoses are the example for aldose sugars. Erythrulose is the example for keto sugars in tetrosis. Third one, pentosis. C5H10O5 is the molecular formula for pentosis. Ribose, xylose, lysose, and arabinose are the example for aldose sugars. Ribulose and xylulose are the example for keto sugars in pentosis. Fourth one, hexosis. C6H12O6 is the molecular formula for hexosis. Glucose, galactose, mannose, allose, maltose, talose, etc. are the example for aldose sugars. Fructose, it is also called as levulose. And sorbose, psychose, tagatose are the example for keto sugars in hexosis. Fifth one, heptosis. C7H14O7 is the molecular formula for heptosis. Pseudoheptulose is the example for keto sugars in heptosis. These are some important points regarding the classification of monosaccharide. Next, we can see properties of monosaccharide. Here we can see color. Monosaccharides are colorless. Shape, they are crystalline compounds. Solubility, they are rapidly soluble in water. Taste, they have a sweet taste. Fifth property of monosaccharide is optical activity. Monosaccharides are optically active compounds. They rotate by plane polarized light. Monosaccharide rotates to right by the action of plane polarized light. This process is called dextrorotation or deform. If the monosaccharide rotates to left by the action of plane polarized light. This process is called levorotation or L form. The sixth property of monosaccharide is mutarotation. In the previous point, I am already told that monosaccharides are optically active compounds. Due to this property, monosaccharides also shows mutarotation. Mutarotation means change in specific rotation. Example, alpha D glucose has a specific rotation of plus 112.2. When we prepare the solution of alpha D glucose, the rotation fall to plus 52.7. And if we adding some catalysts like acid and alkali and heat the solution, we can see gradual change in specific rotation. This process is called mutarotation. Seventh property of monosaccharide is glucoside formation. Here we can see the reaction. Glucose react with methyl alcohol in the presence of HCl gas to form methyl glucoside. Some fructoses also form fructoside. Eighth property of monosaccharide is osazone formation. Sugar molecules contain aldose and ketose functional groups. These functional groups react with phenyl hydrogen and form osazone. This osazone formation may be occur in three steps. In the first step, one molecule of phenyl hydrogen react with one molecule of aldoses called hydrazone. In the second step, second molecule react with phenyl hydrogen called aldohydrazone. In the third step, third molecule reacts with aldohydrazone and form osazone. Ninth property of monosaccharide is oximes formation. Here we can see the reaction. Glucose react with hydroxylamine and produce aldoxime and water. This process is called as oxime formation. Tenth property of monosaccharide is reaction with HCl. This reaction is based on the color and it is also called as Molist test. When exos like glucose reacts with concentrated HCl, it forms hydroxyl perfural complex, which gives purple or blue color ring. 11th property of monosaccharide is reaction with HCl. Here we can see the reaction. Glucose reacts with hydrogen cyanide and form glucose cyanohydrin. 12th property of monosaccharide is reduction. Monosaccharides can be easily reduced by various reducing agent due to the presence of free aldehyde and ketone group. 13th property of monosaccharide is reducing agent, which is related to 12th property. Here, identification test of glucose uses different reducing agent like as Tollens reagent, Fehling's reagent. Here we can see the reaction. Glucose react with Tollens reagent forms gluconic acid, which gives silver mirror. It is the main feature in Tollens reagent test. Next, glucose react with Fehling's reagent forms gluconic acid. If the test gives positive, then forms reddish color. 14th property of monosaccharide is esterification. Here, glucose reacts with acetic anhydride and form esters. This process is called as esterification. 15th property of monosaccharide is enolization. Glucose, fructose, monos are inconvertible in weak alkaline solutions such as CaOH2, BaOH2 at low temperature. This process is called as enolization. The 16th property of monosaccharide is caramelization. When monosaccharide is added with concentrated alkali, it is bluerant and forms specific structure. This process is called as caramelization. 17th property of monosaccharide is fermentation. Here, glucose in anaerobic condition gives ethyl alcohol and CO2 during fermentation in the presence of zymase. 18th property of monosaccharide is phosphorylation of hexose. Here, glucose gives glucose 6 phosphate in the presence of hexokinase enzyme. This is the pathway of glycolysis. 19th property of monosaccharide is Killiani-Fischer synthesis. Here, aldopentoses like arabinose gives aldohexoses like glucose molecules. Next, we can see the examples of monosaccharides. First one is glucose. C6H12O6 is the molecular formula for glucose. It is also called as grape sugar or dextrose occur in fruits and honey along with fructose. In the body, during digestion, it is present in the blood and in the intestine. Glucose forms equilibrium mixture of alpha and beta glucose in the water. It is also called as main metabolic fuel. In this slide, we can observe the structure of glucose. Here we also observe glucose containing aldehyde group means CHO group and 6 carbon ring. Hence it is also called as aldohexose. Here we can see both Fischer's and Haworth structure of glucose. Next example is fructose. C6H12O6 is the molecular formula for fructose. Fructose or fruit sugar is also known as levulose. Fructose composition is similar to glucose but only differences in functional group. Fructose containing ketone functional group, hence it is called as ketohexose and is less rapidly absorbed by the cell. This is due to the difference in position of OH group. When fructose enters to the liver or intestine, it is changed to glucose. In this slide, we can observe the structure of glucose. Here, we also observe the both Fischer's and Haworth structure of glucose. Next example is galactose. It is found in milk, hence it is called as milk sugar and made by lactose along with glucose. Galactose is a part of glycolipids and glycoproteins. During digestion, each molecule of lactose hydrolyzed into glucose and galactose. Galactose is changed into glucose for utilized in the body and is absorbed most rapidly. Here we can see the structure of galactose. Next example is mannose. Mannose is produced by the hydrolysis of plant monozones and gums. Mannose is the constituent of prosthetic polysaccharide of albumin, globulin, and mucoproteins. Mannose also occurs in glycoproteins. In animals, it changes to glucose before being used in metabolism. Here we can observe the structure of mannose. Last example for monosaccharides is amino sugars. It is also called as hexosamines. In amine sugars, a hydroxyl group of the aldose is replaced by an amino or acetyl amino group. Glucosamine, galactosamine, acetyl glycosamine, etc. are the example for amino sugars. Glucosamine occurs in chitin constituent, hyaluronic acid, heparin, mucopolysaccharide, and other bacterial polysaccharides. Galactosamine is found in chondroitin. The mixture of galactosamine and chondroitin is widely used by people with osteoarthritis, that is degenerative germ disease. Here we can see the structure of amino sugars. Here I give the two examples for amino sugars, that is glucosamine and galactosamine. Next we can see functions of monosaccharide. There are two major functions of monosaccharide. First one, major source of energy. We can say glucose is an energy molecule and also main energy fuel in our body. When its chemical bonds are break, energy is released. Second function is components of oligosaccharide and polysaccharides. We all are know about oligosaccharide formation. Oligosaccharides are formed when more than two monosaccharides are combined to each other. In the same way, polysaccharides are also formed when more than 10 monosaccharides are combined to each other. For that reason, monosaccharides are also used as a building blocks to form more complex sugars, which are important structural elements. I hope from this video you can understand about monosaccharide and get some information about monosaccharides. Thank you.